stuff for a few days now, but it feels good to be back on track since a few hours ago.
Good. Yeah, no worries. I'm on vacation with my uh, uh, friend up in Sook Harbor and then on Victoria Island. So
Oh, cool.
yeah.
What did you do?
What's that?
What did you do?
Oh, we're just hanging out. Well, there's a lovely kind of restaurant and hotel here in the harbor that we're staying at.
Nice.
Yeah, yeah. We went for a good walk. I put my feet in the Puget Sound. It's very cold, but it was
Mm.
lovely. Uh, while we're waiting for others, I'll um, while we're waiting for others, I'll mention that yeah, your intuition about map is totally reasonable.
Okay, cool.
Yeah. Uh,
Oh, I had a quick question for you,
yeah.
Greg. Um, what was it though? Oh yeah, so I was looking at the PDF with that showed the
Yes.
VM machine.
Hmm.
And one thing I was wondering here, let me open it up again. Let me scroll up and find it. Oh man, I flooded the Casper channel with WASM stuff. Sorry.
No worries. No worries. That's what it's there
Uh,
for.
well, we finally made a new channel.
Oh, do you mind inviting me to that?
Oh yeah, sure.
Sweet.
Andrew Miller. What was the name of that paper? Oh, here we go. Got it. Casper. So, where we go from, so you have surface type, and then the surface, so it's like on the paper,
Yeah.
you have the surface type system, sublanguage compiler, then core type system, domain calculus compiler, abstract machine compiler, VM, right?
Yeah. Exactly.
Um, so that's the architecture of modern runtime. Where is the so what I was thinking is the core type system in domain calculus um, should essentially be part of the kernel or the hypervisor. So, like, if you think about the VMs, and all we have is a bunch of we have is a bunch of VMs that contracts live in,
Yeah.
and they talk to each other via some IPC, which is facilitated by the kernel, right?
Right.
So, wouldn't it make sense to put the domain calculus, those rules in the core type system, in like the API for the API for the kernel.
Yes. That's absolutely one way to think about it. Yeah. Um,
Okay, because
yeah.
that's sort of the way I was designing EVM2.
Mhm.
I just want to make sure that it's compatible with this view of the world.
Yeah, absolutely. No, that's perfectly reasonable. I think the main thing is I just want to make sure that we all kind of have some agreement on what the calculus looks like. And right now, the only calculus that I can make work in the compositional fashion is the uh, uh, the the reflective calculus. Um, because my requirement is that the um, how do I say my requirement is that each transition step or the principal transition step in the VM is backed by consensus. But that means that, well, how do you write down the consensus? Well, the consensus is written in terms of, a sort of nested VM, and the transition steps in that VM are backed by consensus, et cetera, et cetera, et cetera. So,
Right.
yeah, so it's kind of ends up, it's like this weird reflective recursive thing. And so that has to be kind of argued over as to whether or not that's realistic.
Right.
Yeah.
In your description of the Casper rule, how does it bottom out? How does the recurse? How is it well founded?
So it's essentially all you have to do is you have to get to a state that's recognizable and has certain associative properties. So like if you look at the annihilation rule, there's nothing super special about 0, right? It's just, what you have is you have P and Q run to some state, and as long as that state is effectively recognizable and has certain properties regarding associativity, then you can replace 0 with any state. And so the state that you want is basically the updated state that updates the blockchain, right? So you have essentially you're going to have some blockchain state, and then you're going to move to some updated state that reflects the transition.
Right.
Yeah, that's the key idea. I'm in the process of writing that down. I mean, now that I know that I can, it's in the reflective setting. It's safe to use the higher level contract language to describe the lower level synchronization. So now I can write that down in a way that's like a little bit more understandable.
Right.
Yeah.
Cool.
Yeah. I wonder.
It feels like Ethereum might develop into a strange loop at some point.
I think you're right. I think that's it exactly. Trying to find the document myself. I don't know. Did either of you guys have a chance to look at the betting on propositions note?
No.
Okay. All right. If you get a chance, that's probably worth taking a look at, because so basically when Vlad Vitalik and I were talking a few days ago, it became clear that if you bet on both blocks and state roots, then you have the potential of inconsistencies between bets that become hard to check if you've just got the state root. And since the point of betting on state roots is really to kind of bet on kind of aggregate information about the blockchain, it kind of occurred to me that if you could bet on propositions about the blockchain, then that would kind of give you more fine-grained detail without having to suffer the combinatorial explosion.
Right. So where can I find these notes?
Yeah. So here, I was just pulling them up. Here's the Google Doc paper. I'm just pasting it in at the bottom of the Skype channel again. I think that's them. Let me just double check.
Oh, right. Yeah, I saw this when I came home from the club at 9 in the morning, and
good for you.
Yeah.
What kind of club was it? Was it?
Berghain, maybe you know it.
I'm sorry, you cut out. I couldn't hear.
Oh, right. It's a techno club. It's called Berghain.
Oh, cool. Yeah, my friend Martin Berger who is also a world-class process calculus researcher.
Hmm.
Used to do a lot of techno music and DJing.
Cool.
Yeah. Well, do you guys have any other stand-up questions? Um,
Uh,
you want to do an update, either of you, on your researches?
sure, I'd love to. Sorry, I got sidetracked here though. Um, so yeah, I was just working on the interface for EVM. Oh yeah, I had a question for you about flagellin.
Uh, uh-huh.
Um, so if I understand correctly, you're building flagellin into it's like part of the language, right?
Oh, you're talking about phlogiston?
Yeah, phlogiston.
Yeah, well, so the point of that little piece of work was just to show that you don't have to have the VM be metered, that you can do all the metering and monitoring as an in-language translation. So the core calculus is not metered, and then you have a kind of metering uh, harness translation, and then that executes against the VM. So that's one way to um, one way to address it. Now on the flip side,
Hmm.
I was recently so Mike Stay and I have a higher categorical semantics for the pi calculus, and one of the crucial pieces of that semantics is a reification of the evaluation context. And when we were looking at it again last Monday, I realized that I have that 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 looks also a lot like metering and monitoring. In fact, we even make this point in the paper we presented in Poland last year. Um, but I hadn't really thought about those results in the context of Ethereum. And so the reason this is relevant to this discussion is because that places the metering and monitoring at a more fundamental level. So there might be an argument that I'm not seeing for putting it down in the VM level. So I'm kind of thinking about that more carefully.
Have you looked at um, asynchronous circuits, or have you heard of asynchronous circuits?
Well, I mean, I've certainly heard of them in the hardware setting. Yeah, I, I I've seen Ivan Sutherland talk about that kind of stuff for decades.
Right. So like metering is for me like a direct seems like a direct predecessor, or it comes from the idea of having a clock speed, right?
Hmm.
So I was trying to envision what it would like to have something like metering, but coming from an asynchronous circuit point of view where there is no clock speed. So would the equivalent be something like um, how many wires a certain operation used, maybe? I don't know.
Yeah. So if you one way, that's a great question actually. So and Vlad and I have been talking about this, like if you allow for concurrent execution within the VM, how do you ensure that the transaction IDs color those transactions or those transitions in the VM, which are directly correlated to that transaction, so that you can charge to the right party,
Uh-huh.
right? Uh, and that's an argument very much in favor. I believe at this point is very much in favor of the transition of the translation approach to metering and monitoring, because in the translation approach I can color every step that's related to a particular transaction, like with a transaction ID. And so you can get, and that's even in the presence of concurrent execution.
So when you say color, what do you mean there?
I mean, I can somehow mark it. I
Okay.
can somehow say, okay, this step is related to this transaction ID, and that step is related to that transaction ID. In the formal presentation, I do that by having, because the namespace has structure on it, I can insist that the names that are associated with a particular transaction ID all have a little marker inside them that indicates the transaction ID they're associated with. At a higher level, what that comes down to is a kind of parameter passing.
Okay, that's interesting. So what I'm working on this week and next week is metering explicitly and just metering, probably. I think I'm not doing something as complex as what you're doing or thinking about doing with coloring. I'm just doing an AST transform.
Yeah, no, that's exactly it.
So I get a AST in, and then I traverse the AST. I do a depth first transversal, and then after I find all the leaf nodes, I ascend back to the top. And then on the way back up, if I hit any branch conditions, like an if, let's say if we can think of an if as having some test statement and then having a consequence statement, and then maybe if it has an else, like an alternative statement, right? So you have to then, after every branch condition, you have to add a piece of code that does the counting. So one for the consequence and one for the alternative. And then you keep on transversing up and counting like all the AST nodes. And you keep running count of the gas, and then keep injecting it into every branch condition.
Yeah, no, that's exactly right. So that's basically an argument very much in favor of the position that I was taking, which is that it can be an in-language translation. Right, AST to AST. That's what the phlogiston argument is.
Right.
It's an in-language translation. It doesn't have to be, doesn't have to be a part of the VM at all.
Right. That's the way I'm making it.
Yeah.
But right now I'm just doing the transform on a WASM bytecode, which is in an AST. But it should be easy to, like, let's say if you had a higher level language and when you added support explicitly for the higher level language, you could put the transform in a parser for the higher level language.
Exactly. That's exactly the idea. That's correct.
But as it stands now, you can also, after I get this prototype done, you'll also just be able to use like Rust or Go, and it'll compile into a WASM AST, and then you can get metering for free.
Yeah, no, that's it. And the nice thing about that is that then the proof of the correctness of execution is kind of at the right level, right? So in the little note that I made, the point was first what characterizes correct execution, and for me, what characterizes correct execution is that in the presence of enough gas. So like if you have enough resource, then the execution of the metered program has got to be equivalent to the execution of the non-metered program. They ought to be exactly the same.
Right. Yeah.
So then the limitation is just whether or not you get to have coverage of all the different code paths. Cool. That's awesome. So that makes me happy. So it sounds like your implementation and the theory are lining up. Bravo. Well, I'm always happy to end these early, unless there's any other updates. I'm good myself. Jack, did you have any updates or questions?
Not really any updates. I do have a question regarding what you guys just talked about, though.
Yeah, sure.
I didn't understand completely. So if we get a conditional, and let's say that the consequence is the cost of running, that would be 100 phlogiston, and the cost of running the alternative would be 10. What what would the cost of the if else be, of the conditional be? Would it be the maximum of those, or maybe I'm not understanding the idea correctly?
Right. So you can think of the like the if statement as a node in a graph, right? And
Yes.
it's going to have three branches actually. It's going to have the test condition
Right.
as
Yep.
one branch, and then the consequence branch, and then the alternative branch.
Hmm.
We know the test condition has to happen every single time, so
Exactly.
we're not going to count that. We're only we'll sum the amount of computation it does into the parent node. So for the consequence and alternative, we take that subtree and we add it up. We figure out how much gas it's going to cost, and we add we add a statement at the beginning, the first statement of the consequence, and the alternative branch is going to be a gas addition. So we'll add how much gas is going to cost to run the whole subtree below it.
Oh, okay. I see.
Yeah, so as I understand you, Martin, what you're saying is that this is a runtime calculation versus something that you know up front. You can't
Yeah.
know the total amount of gas until you actually execute the code.
Right. Well, we do the AST transform, and we inject the counting in places where there's branch conditions where we won't know till runtime.
Yeah, exactly.
But
And then,
everything that we can know from static analysis of the AST gets put up front. So it should make gas actually, it should make metering a lot more efficient than our current setup.
Yeah, that makes sense. So Jack, my understanding of Martin's answer is that from an upfront calculation, if you took the max as you suggested, that would be a safe bet.
mhm.
Yeah.
But it wouldn't be as tight as developers would want it to be.
Correct. That's right. Yeah.
But okay, so follow-up question then, with the cost that you actually can know statically, would it make sense to perhaps encode them in the type system using dependent types?
Ooh, that's a really interesting idea. That's a really interesting idea. I wonder what the cost though would be.
Yeah,
Yeah, so type checking at that point might get really expensive.
might be true. It's just an idea that I had right now.
Yeah. No, I think it's definitely worth exploring.
Mm.
Yeah.
Well, at this level that I'm working at, we do have types, but I think they're different from what you guys are talking about.
Yeah.
We have 32-bit integers, 64-bit integers, and then 32-bit floats and 64-bit floats.
Yeah, I think what Jack is referring to is a kind of a richer type system in which values play a role in types.
Oh,
Yeah. So
higher level types.
yeah, exactly. They're parametric on values. So you'll get types which are parametric in values, which would allow you to do things like type, at static compilation time, with information about, reasonable amounts of gas to spend. Just, the program wouldn't even be well typed because you just don't have enough gas to spend on it.
Hmm.
Yeah, which is kind of cool. The problem then is that the computational complexity of type checking at that point might get really big.
Right. Yeah.
There could be traveling salesman problems hiding in type checking at that point.
Wow.
Yeah. Cool. Well, this is really good, and because I'm on vacation, I'm going to suggest that we're that we end at this point, and we'll chat again next Monday.
Wow, we actually had a regular stand-up almost.
I know. All right. Talk to you guys soon.
Bye.
Yeah. See you. Bye.